In this video, I am going to discuss chemical properties of alcohols. Chemical properties of alcohols. So, main reason for the chemical reactions of alcohols is very reactive OH group is present. Very reactive OH group is present in the alcohols. So, chemical reactions are takes place by the cleavage of two different bonds. That is, one is carbon-oxygen cleavage, carbon-oxygen cleavage. Second one is oxygen-hydrogen cleavage, carbon-oxygen and oxygen-hydrogen cleavage. Carbon-oxygen cleavage mainly takes place in tertiary alcohols. Carbon oxygen bond cleavage mainly takes place in tertiary alcohols due to presence of three alkyl groups. Three alkyl groups because these are plus I effective groups. These are plus I effective groups because of plus I effects groups of alkyl groups. So carbon oxygen bond is weaker. This carbon oxygen bond is weaker in the case of tertiary alcohol. So in the case of tertiary alcohols, carbon oxygen bond cleavage takes place. So next one is oxygen hydrogen bond cleavage. So here oxygen hydrogen bond cleavage mainly takes place in primary alcohols. In primary alcohols, only one alkyl group present on the oxygen bearing carbon atom. On the oxygen bearing carbon atom. Due to here oxygen hydrogen bond is weaker in the case of primary alcohols. Oxygen bond is weaker. So due to the primary alcohols are mainly oxygen hydrogen bond cleavage takes place. So here order of reactivity of alcohols by the cleavage of oxygen hydrogen. Primary more reactive than secondary, secondary more reactive than tertiary. So tertiary is the less reactive to the cleavage of carbon oxygen bond. During the carbon oxygen bond, alcohols can show acidic nature. Acidic nature. During the oxygen hydrogen bond cleavage, alcohols can show acidic nature. So, but this acidic nature is weaker than water. Acidic nature of alcohols weaker than water. Due to in water molecule no alkyl group is present. In water molecule no alkyl group is present because oxygen hydrogen bond is weak. Oxygen hydrogen bond is weak. They can access strong acid than alcohol. In the case of alcohols, plus I effect alkyl group plus I effect of alkyl group is present. So this is the strong when compared to the water. This is the strong. So alcohols can act as weak acids than water due to the presence of plus I effective of alkyl groups. Plus I effective of alkyl groups. So among the different types of alcohols, acidic nature. So tertiary, sorry, order of acidic nature of acidic nature of alcohols. So primary alcohols more acidic than secondary and tertiary alcohols are least acidic because of in tertiary alcohol three alkyl groups are present. Alkyl groups are present, oxygen hydrogen bond will be strengthened due to the reason for the acidic strength of alcohols. So next one we have to discuss reactions. So that is the first one is reaction of alcohols with metals. First one is reaction of alcohols with metals. First reaction is reaction of alcohols with metals. Reaction of alcohols with metals. Alcohols when react with metal to form metal alkoxide and evolve hydrogen. For example, this is a alcohol. It reacts with metal like sodium or potassium. They can give metal. They can give metal alkoxide. This is the metal alkoxide. Metal alkoxide and evolve the hydrogen gas So here metals acts as bases and alcohols acts as acids. Metals acts as bases, alcohols acts as acid. So these reactions are called as acid-base reaction. These reactions are called as acid-base reactions. Acid-base reactions. So in the same way, alcohols can react with metal hydrides also. Alcohols can react with metal hydrides also. They can give metal alkoxide and also evolve the hydrogen gas. For example, I am taking ethyl alcohol CH3CH2OH and it gives reacts with potassium. It gives potassium ethoxide CH3CH2OA and releases hydrogen gas. In the same way, alcohols can react with Grignard reagent also. Alcohols can react with Grignard reagent. This RMGX is the Grignard reagent. So here gives alkanes. Here alcohols can use alkanes and alkoxy magnesium halide. Alkoxy magnesium halide. For example, methyl alcohol react with CH3MgBr, methyl magnesium bromide. Here it forms methane and methoxy magnesium bromide. Methoxy magnesium bromide. Methoxy magnesium bromide. So here in these reactions, alcohol, all the reactions, alcohols acts as acids. So now we have to discuss about the acidic nature of alcohols. Acidic nature of alcohols. First of all, what is the reason for the acidic nature of alcohols? So, reason for the acidic nature of alcohols has polar oxygen hydrogen bond. Alcohols has polar oxygen hydrogen bond. In this oxygen hydrogen bond, two electrons of the bond attracted by the oxygen atom. Two electrons. Here, two electrons will be present. One is the oxygen electron, other one is the hydrogen electron. Hydrogen electron also attracted by the oxygen atom. So here they can exhibit more polarity. More polarity. Because of polarity, possibility to produce the H plus ion. Because of produce the H plus ion, alcohol acts as acids. Alcohols acts as acids. So here it forms alkoxide ion and releases H plus ion. But hydrogen releasing in takes place not easily. But hydrogen releasing takes place not easily. So even though in presence of strong bases like NaOH or KOH, so here reaction does not take place because this is the even though strong base alcohol does not react with NaOH because of it is very weak acid. It is very weak acid. Highly strong active metals. In the presence of only highly strong active metals only they can give they can access acids. So gives alkox, metal alkoxide and evolves hydrogen gas. So this is the reason for the weak acidic strength of alcohols. So here we have to already discuss alcohols are weak acids than water. Weak alcohols are weak acid than water. Weak acid than water due to the presence of plus I effect of alkyl group. Plus I effect of alkyl group. So for example, RCH2OH. Here, this is the plus I effect alkyl group. Because of plus I effect, polarity of oxygen hydrogen decreases. So, possibility to release the H plus ion from this hydroxyl group. This is the reason for the weak acidic strength of alcohols. So, among the different types of alcohols, order of acidic strength of alcohols, order of acidic strength of alcohols among the different types of alcohol, among the acidic strength of alcohols among the different types of alcohols. Mainly alcohols are three types: primary alcohols and secondary alcohols and tertiary alcohols. Among these three alcohols, order of acidic strength, primary alcohols are more acidic than secondary and tertiary alcohols are weak acidic. In the tertiary alcohols, in the tertiary alcohols, in the tertiary alcohols, three plus I affecting groups are will be present. Three plus I affecting groups are will be present. Because of plus I effect, here oxygen hydrogen bond polarity is electron density increases on the oxygen atom. In the here possibility to break will be difficult. Will be difficult. So tertiary alcohols can act as weak acids. So in the secondary alcohol, two alkyl groups are present. Two alkyl groups are present. So compared to the tertiary alcohols, number of plus I effective groups are decreases. So acidity is more when compared to tertiary alcohols. Sorry, acidic strength is more. So compared to tertiary and secondary, primary alcohols has only one plus I affecting group, only one plus I affecting group due to the number of less plus I affecting, it acts as more acidic strength. More acidic strength. This is the reason for the order of acidic strength of different alcohols. Now I am going to next reaction, that is dehydration. Dehydration of alcohols. Second reaction, that is dehydration of alcohols. Alcohols when react with acid heating in the presence of acids like concentrated H2SO4, and phosphoric acid H3PO4, or alumina Al2O3, or phosphorus pentoxide. These all are acts as dehydrating agents. They all are acts as dehydrating agents. But here different temperatures are required with different acids. For example, concentrated H2SO4 acts as dehydrating agent at 170 to 180 degrees centigrade. 170 to 180 degrees centigrade. Here, alumina acts as dehydrating agent at 360 degrees centigrade, and phosphoric acid acts as dehydrating agent at 240 to 250 degrees centigrade. Here, yes, temperature is required. So, different temperatures are required for the dehydration of alcohols with different types of different acids. So, for example, I am taking primary alcohol CH3, CH2OH. So, it is heating in the presence of concentrated H2SO4 at 170 to 180 degrees centigrade. Dehydration takes place. Dehydration takes place. So gives alkene and releases water. So here 180, 170 to 180 degrees temperature is required. If I am taking, this is primary alcohol. If I am taking secondary alcohol, CH3, CH, CH3, OH. Now here only 85% of phosphoric acid required, and temperature also 440 degrees Kelvin is enough. Here temperature also 440 degrees Kelvin is enough. So here also dehydration takes place. Here also dehydration takes place, like it forms alkene CH3, CH double bond, CH2 and releases water. So in the case of tertiary alcohols, in the case of CH3, CH3 and CH3 OH, here only 20% of H3PO4 phosphoric acid is required, and temperature 358 degrees Kelvin is enough. 358 degrees Kelvin temperature is enough. So it gives dehydration takes place, gives alkene CH3, CCH3 double bond CH2 and releases water. So among the three reactions we can conclude, so easy of dehydration takes place in tertiary alcohols, because in tertiary alcohols just 20% of phosphoric acid and just 358 degrees Kelvin temperature is enough for the dehydration. From this we can say easy of dehydration takes place in tertiary alcohols. In the case of secondary alcohols, 85% of phosphoric acid and 440 Kelvin temperature is required. This is strong conditions when compared to the tertiary alcohol. So next, easy of dehydration in the case of secondary alcohols. So in the case of primary alcohols, 443 Kelvin, 170 nothing but it is 443 Kelvin, and highly drastic conditions are required in the case of primary alcohol. So this is the order of reactivity, order of dehydration in the case of different alcohols. So easy dehydration takes place in tertiary. So dehydration difficult in the case of primary alcohols. So dehydration involved in the elimination mechanism. Dehydration involved in the elimination mechanism. So elimination also primary alcohols involved in E2 elimination mechanism, and secondary and tertiary alcohols secondary and tertiary alcohols involved in E1 elimination mechanism. E1 elimination mechanism. E1 elimination mechanism. In E1 elimination mechanism, stable carbocation is formed. Stable carbocation is formed. Stable carbocation is formed. Because of stable carbocation, rearrangement is possible. Rearrangement is possible because of stable carbocation is formed. Because of carbocation formation, rearrangement also possible in the case of E1 mechanism. So here, if possibility of formation of two products, for example, this is the OH group. Now, dehydration reaction takes place in the presence of concentrated H2SO4 at 170 degrees centigrade. So, possibility of products, two types of products are possibility. So, here gives one is this one and other one is this one. Which one is major according? Which one is major? So, this is the major product. This is the minor product. This is explained by the Sergeff rule. So, Sergeff rule nothing but more substituted alkene. Here, for this alkene, alkyl group is substituted. Methyl group is substituted. So, for this alkene, no substituted group will be present. Because of, according to the Sergeff rule, more substituted alkene is major due to the hyperconjugation. Due to the more hyperconjugation structures. Hyperconjugation structures. So this is the regio. It is called as regioselective. In the formation of product, two products will be formed. In that, one is the major product, then other one, it is called as regioselective. If only possibility of one product, that is called as regiospecific. Possibility for the two products, in that one product is major than other product, it is called as regioselective. If only one product is possible, that is called as regiospecific. Reaction of alcohols with hydrogen halides. Alcohols, when react with the hydrogen halides, they can form the alkyl halides. Alcohols reacts with hydrogen halides, they can form alkyl halides and releases hydrogen halide. So, based on the different types of alcohols, we can prepare the different types of alkyl halide. For example, if I am taking tertiary alcohol, they can give tertiary alkyl halide. Tertiary alkyl halide. If I am taking primary alcohol, they can give primary alkyl halide. Primary alkyl halide. So here, order of reactivity of alcohols and order of reactivity of hydrogen halides towards this reaction. So, tertiary alcohols are more reactive than secondary, and primary alcohols are least reactive towards this reaction. This is about alcohol. So, in this hydrogen halides, hydrogen iodide is more reactive than hydrogen bromide, and hydrogen chloride is least reactive. Hydrogen fluoride does not react in this reaction. Does not react in this reaction. So when primary alcohols reacts with hydrogen chloride, Lewis acid like ZF with hydrogen chloride, Lewis acid like ZnCl2 is required because ZnCl2 forms the complex with alcoholic group to access better leaving group. This is the reason for the very less reactive of HCl. So when primary alcohols reacts with HCl, zinc chloride is compulsory. In the presence of zinc chloride only, primary alcohols reacts with HCl. Even though zinc chloride is present, some of heat also required. Even though zinc chloride is present, for the reaction of HCl with primary alcohol, heat also required. But in the case of secondary and tertiary alcohols, reaction with HCl, so ZnCl2 does not require. Zinc chloride does not require because of. So secondary and tertiary alcohols more reactive than primary alcohols. Secondary and tertiary alcohols more reactive than primary alcohols. They can form tertiary alkyl halides. For example, reaction of ethyl alcohol with hydrogen chloride in the presence of zinc chloride, and some amount of heat also required because alcohol is primary alcohol. So it will give ethyl chloride. And water. So if I am taking tertiary alcohol, reacts with hydrogen bromide. So here tertiary alcohol reactivity is more and hydrogen bromide reactivity also more due to these two reaction takes place without ZnCl. So it will give tertiary alkyl bromide, and it will give add water. So next reaction of alcohols with phosphorus pentachloride. Reaction of alcohols with phosphorus pentachloride. Fourth reaction of alcohols with PCl5. Reaction of alcohols with PCl5. So alcohols when reacts with phosphorus pentachloride, it will give alkyl chloride and phosphorus oxychloride and HCl. So 1 mole of alcohol react with 1 mole of phosphorus chloride.